For millions of years, the Earth operated in a brutal, meticulously balanced rhythm. It was the late Cretaceous period. Herbivores fed on continent-spanning forests of ferns and conifers, while carnivores timed their hunts to the first light. Every heartbeat and every casualty served a specific, entrenched role in the ecosystem. At the absolute apex of this food chain stood the Tyrannosaurus rex. With over 2 tons of muscle and crushing jaws, it was the undisputed biological ruler of the landmasses. To fuel an ecosystem populated by giant predators, massive herds of herbivores crossed the plains. Creatures like the Triceratops acted as living shields. Their dense, bony armor and horns evolved specifically to survive in a world where the hunters were the size of modern buildings. Far below the gaze of these colossi, a different struggle played out. Early, primitive mammals were confined to the shadows. Alert and wary, they lived mostly underground or deep in the undergrowth, entirely subjugated by the sheer size of the reptiles above. The giants held every major ecological niche, creating a biological status quo that favored scale over adaptability. In a world where every scrap of territory and energy was already claimed by the dinosaurs, the smaller, shadow-dwelling mammals had no clear path to dominance. But millions of miles away, isolated from this terrestrial dominance, a 10-kilometer-wide fragment of rock was moving through the darkness. Born from the collision of ancient celestial bodies, it had been drifting silently across the asteroid belt. This diagram shows the orbital mechanics that sealed the planet's fate. For eons, the asteroid's path remained harmless, but eventually it hit the point of no return. It crossed into Earth's gravitational field, accelerating past the Moon's orbit and locking on to a direct collision course. As it slammed into the upper atmosphere, the friction compressed the air in front of it. The rock heated up exponentially, igniting into a fiery orb that lit up the daylight sky with the intensity of 1,000 suns. In less than a breath, an invisible speck in the vacuum of space became an unavoidable planet-killing force. It proved that biology, no matter how dominant or perfectly adapted, is ultimately subject to the raw physics of the cosmos. The target was the Yucatan Peninsula, where the landmass curves into the Gulf of Mexico. The asteroid struck at over 70,000 kilometers per hour. The energy release exceeded 100 million megatons. The sea vaporized instantly, folding the Earth's crust to form a 180-kilometer crater. The atmospheric displacement triggered a global tsunami more than a kilometer high, scouring coastlines thousands of miles away. Simultaneously, a supersonic shockwave flattened surrounding forests, bending massive trees until they disappeared in the heat. Then came the Ejecta, millions of tons of rock and metal blasted into space by the initial strike, lost momentum and fell back down. They returned incandescent, striking the planet in a continuous shower of fire that ignited global wildfires. Surface temperatures spiked violently, exceeding 1,000 degrees. The air became a furnace. The largest dinosaurs caught in the impact zone and surrounding regions collapsed, suffocating in extreme heat. While the wall of fire was devastating, the kinetic explosion itself wasn't the final killer. The true extinction trigger was the catastrophic, instantaneous climate trauma that eradicated the surface habitat. The impact pulverized millions of tons of rock into a fine, dense ash. Lifted high into the atmosphere, this dust layer remained suspended for years, effectively blocking out the sun and plunging the planet into a freezing twilight. This diagram illustrates the trophic cascade. With sunlight blocked, photosynthesis stopped. Massive ferns and conifers died off, taking the food supply of herbivores with them. When the enormous herd starved, the predators followed. The massive biological engines of the T-Rex simply ran out of fuel. Conversely, the creatures that had been historically subjugated, tiny insects and mammals, possessed a distinct advantage. Their low caloric needs and ability to take refuge in underground burrows allowed them to weather the freezing darkness. The event revealed a bitter irony. The size and power that made the dinosaurs kings became their fatal flaw. In this ruined landscape, the smallness of the mammals became the ultimate metric of survival. Decades passed. Slowly, the heavy blanket of dust began to settle. The sun, weak and pale, filtered through the clouds, and the surface ice finally began to melt across the blackened plains. Rainwater penetrated the cracked soil, reaching seeds that had lain dormant. Life took root. Moss clung to the rocks, and ferns uncurled among the burnt trunks, turning the barren earth green once more. When the survivors finally climbed out of their burrows, they found the plains empty. The colossi were gone. The agile mammals that once lived entirely in the shadows now had unrestricted access to the planet's rebounding resources. The catastrophe cleared the terrestrial landscape. By removing the established order, it shifted the planet's evolutionary trajectory away from reptiles, allowing mammalian life to expand into the vacant niches. The evidence of this global reset is physically buried beneath our feet. The sudden end of the dinosaurs is etched into the rocks, verified by massive bones locked under millions of years of silence. With the apex predators removed, mammalian evolution followed a new path. The clearing of the Old World created the specific ecological opportunities that would eventually lead to the rise of intelligent, sky-watching primates. The Chicxulub Impact was the catalyst that shifted the Earth's biological focus. By clearing the giants, it provided the specific environmental opening that our ancestors eventually climbed through to reach us.